Hello, everybody, and welcome back to Pycon AU 2024. Next, we will be having Katie Bell, who will be speaking. Now, we are extremely happy to have MongoDB come and sponsor this event, and Katie here works amongst them as a staff software engineer. I've also been told that Ms. Bell is one of the smartest people at Pycon because of her talk about WebAssembly in the previous year, so I'm sure that everybody will learn something from this presentation. Without further ado, I shall let her begin her presentation.
Thank you. I've got a mic.
Yeah.
All right. Yep. No pressure. All right. So yes, I'm Katie. I work at MongoDB. And what is MongoDB? MongoDB is a database. It stores your data. It helps organize it, helps you find ways to aggregate it and pull it out like any good database does. It is source available, which is similar but legally distinct from open source. It is document-oriented database, and it is a NoSQL database. And as we go through, we'll be able to see a little bit more about what that means compared to a regular database. But before that, we're going to do a little bit of audience participation. What do you use to store data in your software apps? Okay, we're going to do a show of hands, and I'm going to pull them up like one at a time. We'll see. Okay, does your app store a bunch of files on disk? I actually work on a desktop app, so like that is a perfectly reasonable way to store information with a bunch of files. In a cloud service. Yep, well, lots of that. All right, what about a relational database? This is Postgres, Oracle. Yeah, see, heaps and heaps of hands for that one. Yep, most of us have used a relational database. Postgres, as mentioned before, is a good one. Oracle, SQL Server, MySQL. They mostly have SQL in the name because that's how you use the database. A NoSQL database, including MongoDB. Yeah, some hands there. Good stuff. How many MongoDB users in the room? Yeah, a couple. Nice. Cool. So we're going to be talking about migrations. Now we have established sort of a lot of people have used a relational database. Some people have used a NoSQL database. We're going to talk about migrating from a relational database into MongoDB. And we're going to talk about that because that's what I work on, and so I am really interested in it, and I have opinions on it. I work on this thing at MongoDB called the MongoDB Relational Migrator. It is a tool that helps people migrate data from a relational database. Several different kinds of relational databases are supported into MongoDB. Now, why would you want to do this? Should I migrate my data to MongoDB? And the answer is probably not. I'm not a salesperson, I'm an engineer. And the reality is that data migrations are really hard. It's a lot of work, especially if I changed slides before you could take a photo of that. I saw that. Data migrations are hard, especially when you're moving from one database to a very different database, one that thinks in a different way, structures the data in a different way, used in a different way. You're not only moving the data around, you're also changing a lot of your application code. And keeping your data in two different places during the migration is also hard. And you generally shouldn't do this unless you have a good reason. When we talk to customers who are trying to migrate their data into MongoDB, we find that developers choose to migrate to MongoDB when they've already used MongoDB for other things and they know that they like it, they know that it's a good fit for their data model, a good fit for their usage patterns. But most importantly, their current data store has some kind of significant cost or limitation that's actively getting in their way, stopping them from being able to develop efficiently for new features. Maybe there's some scalability issues, or the way that they're using the database isn't a good use of that particular database, or they're using a proprietary database that has really expensive licensing on it. There is always like something painful about the existing database that is causing them to move. So I cannot emphasize this enough. If you are happy with your current database, don't migrate. If it's not causing you any issues, please stick with what you're already using. Okay, so we're going to go through an example using the MongoDB Relational Migrator to migrate some data from a relational database into MongoDB. And for that, we need an example app. So here's an example app. It's called Conduit. It's part of a series of example apps written across different frameworks in different languages that all sort of use the same UI. And this is kind of like a blog, sharing article, social media site called Conduit. This one is written with Fast API. So it's written in Python using Fast API. It's using SQL Alchemy. And it has the ability to create an article, to write it, to add tags to it, and publish that article under your account. You can then comment on other people's articles. And you can also follow people to see a curated like a feed of their articles, as well as like favoriting specific articles like a like. So this is the kind of stuff that this app does. And this is the app we're going to use as an example. It uses Postgres. And this is the Postgres schema that it has. So we've dealt with apps that have hundreds and hundreds of tables. This one is a sort of talk-sized example app with only 7 tables. So we have user accounts in one table, we have articles as one table, the tags on the articles as a separate thing, comments are a separate table. And this is a fairly typical relational database schema with sort of foreign key relationships between the different tables. And we're going to zoom in a little bit on tags and article tags as our example. So as an article, when I create an article, I can add tags to that article in this app. And then users can find articles by seeing popular tags and saying, show me all the articles that have Python as a tag, so I can filter by those articles. And in a relational database, we have 3 different tables for this. And since a lot of you are familiar with relational databases, you probably understand why this is. But if you were a beginner and you were just starting out with your first time, you might think, well, why don't we just store all the article information in one table? Why do we have to use 3 tables for this? And so you might do something like this. Who has seen this or done this at some point in the past, or seen someone else do this? I used to teach students to do Postgres and SQL, and I would see this quite a lot. We kind of can't do this in a relational database. We can do it, but it has a bunch of issues in that trying to find all the articles with the Python tag, you have to check all of the different tag columns. And you can only have 4 tags in this example. What if I want to put 10 tags on my article? It becomes kind of cumbersome to do. All right, maybe we store it in one column like this. We could use comma-separated values. If you use Postgres, you have JSON fields. It would actually work pretty well. But in this case, kind of querying it, what if a tag has a comma in it? You have to deal with all of these things. This can get pretty cumbersome as well. So in typical relational database style, you would put the tags in a separate table, and each of these would reference the article ID that it's joined together with. And if you're following the kind of relational schema design patterns that you read about in textbooks, you also see that, we don't want to be storing the same strings like twice. We don't want to be storing Python twice. So we could put that in a separate table and then have these references across, right? So this is how the schema works in our app. This is why we have 3 tables, one for the articles, one to kind of join together which article ID is joined with which tag ID, and then one to store the actual strings of those tags. And because foreign keys are indexed by default, this means that the lookups are very fast as it sort of joins things together. So this is the relational database way of thinking everything is a table, and tables are often joined together by different keys. MongoDB is a document-oriented database. This tends to think about data in a slightly different way. It has this concept of collections, where a collection is a collection of documents, and each document can be thought of as kind of like a JSON document. It has a set of keys and a set of values, and you can sort of keep data in that JSON format. Not every document has to have the same keys, but you can use schema validation tools to enforce that all of the documents follow a certain pattern for the set of keys that they have. So you can make sure that all the documents do match, or you can have very free-form documents. It's flexible in that way. So if we were taking a relational schema and sort of automatically mapping it into MongoDB, we would say, all right, a table could become a collection. So we have an articles table, we have an articles collection. Each row in that table is one document in that collection, kind of one JSON document. And so each column from our table becomes a field in those JSON documents. All right, so this is step 1. Let's migrate some data. So I'm going to take the Postgres database that I have running locally on my machine. You use the MongoDB relational migrator to migrate it to MongoDB. And I'm going to use another tool called Compass, which is just a tool for inspecting a MongoDB database and having a look at those documents so we can see what happened. Okay, and so all of this is running locally on my machine. So this is the relational migrator. This is the tool that I work on. I want to stop and appreciate for a second that like a migration tool has a UI that has actual UX designers working on it. So this surprised me a lot when I started working on this. So I can take no credit for the design. Those actual designers. So we have our relational database schema here, and we can see that there are two schemas. There's my Postgres relational schema and my MongoDB schema. Now I have set these up to be exactly the same. There is one collection in MongoDB for every table in the Postgres schema. So if we zoom in on the MongoDB schema, we can see there's an article collection, an article tag, and an article tag, join table, or join collection, and a tag. So I can go here, I can create a migration job. I'm connecting to my Postgres instance that is running locally, and I'm connecting to my MongoDB. These are both running in Docker locally, and I can start the migration, and that starts running. And I'm going to go to Compass, where I can see my MongoDB instance, and if I refresh here, there's a conduit database that has popped up here, and I can make this bigger. And in my conduit database, I have an article tag collection. So in the article collection, there are only 2 articles. And first, we'll notice that it has these randomly generated unique IDs for each thing. Auto-incrementing integer IDs can be done. You can do that with MongoDB, but it's sort of a bit of a transition. You're usually better off switching to some MongoDB-style IDs if you want to use MongoDB. And we have the fields that we've copied over from our relational database. So this is great, but we have our article tag table here as well, which also has its own additional key, and a tag ID, and our tag collection here as well. All right. So this has some unfortunate side effects in MongoDB. If we tried to copy everything over exactly the same as it was in the relational database, it doesn't actually work that well in MongoDB. Joins between collections, while you can do them and they do work, they're a little bit more expensive, and the way that you write the queries is a little bit more cumbersome. So our relational schema worked really well in Postgres, and we could find all of the articles that use the tag Python using this join query that joins the articles table to the article tag table to the tag table. If we wanted to do the same thing in MongoDB, it'd look a little bit more like this. There's a lookup operation, which is similar to a join, and we're looking up we're looking at the articles collection. This is in Python, by the way. When you specify a MongoDB query, there isn't a separate language, kind of like SQL. We're defining that query in terms of a Python dictionary, or a list of dictionaries here. And so this is a MongoDB aggregation pipeline calling through the MongoDB Python library. So it's looking up the articles collection, and then sort of looking up from that the article tag collection, and then also looking up the tag, and then at the bottom there, matching that the tag matches Python at the end there. And this is not going to be as fast on MongoDB as it is on Postgres. It is not optimized for that kind of join in the way that a relational database is built around the concept of joining tables together and is very, very optimized for that use case. In MongoDB, we can change the way that we structure this data to make it more efficient for a MongoDB way of thinking and a MongoDB way of working. So if I go back to my relational migrator, what I can do here is add another mapping from the table here as an embed. Instead of mapping to a new set of documents in a new collection, I can embed the article tag table inside the article collection. Right? So for each article, it's using that foreign key relationship to know which article tags go with which article document in the JSON documents. And on top of that, I can also add, so I'll save that one. I can add an embedded document from the tag table and save that. So now I have in here article tags and the tag, including the actual string of the tag, as part of this document. So if I migrate this, just going to zoom through this part, start the migration job, go back to my article table, and refresh this. I now have an article tags array of objects in here, and for each one, I can see the individual tag that has come through here. So the migration tool lets us kind of put multiple tables into one collection here, but it's a bit like this is an unnecessary layer of nesting. If it's all in the same document, we don't need a tag ID. We don't need some of this extra information. So I'm just going to go back here and say, OK, for this article tag, I don't care about the article ID because the article ID is already there in my document. I don't really care about the tag ID. I can save that. And for our tag embedded, I can just keep the tag here. And there's a special little setting here which says merge fields into the parent, so it's not embedded separately, it's just a field here. And I'm just going to do one more little change to go back to the article tags and say, I don't want to call it article tags anymore, it's just tags. Okay. So here we have our article document has an array of tags where we can see when each tag was created for this article and the string of that tag. So if I migrate one last time, connect, start, and go back to here, and refresh, I now have a tags array, which has just the tag information and when it was added to this particular article. And if we go back to our query that we're trying to do, if we're selecting from the article, in MongoDB, I can find all of the articles, including all of the rest of the information about the article, just by searching for a particular tag using this. And if I add an index onto that field, this lookup is actually pretty efficient. So that is sort of shifting the way that the data is structured to work with the way that MongoDB structures and the way that MongoDB thinks about data. All right. This is a pretty convenient example. This is a good example of one where I think the MongoDB version is a bit cleaner and more intuitive than the relational database version. This is not true of all different kinds of data. Sometimes translating this is a lot harder and is a lot messier. So I want to take the example of comments. So our articles in this example app have comments on them. And so we could do the same thing here. We could take that comments table and embed the comments for each article as part of the article. And this would make sense. When we load the article page in the app, we often want to see the comments right there. And keeping the same data in the same place means loading it is very efficient. But there's one sort of big thing that can get in the way here, which is that there's a 16 megabyte document size limit. Now, for most articles and for most sets of comments, this is going to be perfectly fine. We can easily fit all of that into into one 16 megabyte document. But if there was one article that had a really large number of comments, like thousands of comments, and those comments were really long, this might actually bump up against the 16 megabyte limit for a single document. So you have to think about that when translating the data into MongoDB, that a document is kind of, in this case, maybe should be more like a row rather than like a whole table in it. So there are a bunch of options that we can use to deal with this. One of them is to just keep the comments in a separate collection and do a join. The joins are not bad. You have indexes on the right fields. Those joins are pretty good. And finding all of the comments for a particular article isn't going to be too bad. We could limit the number of comments. Do we really need to have thousands of comments on an article? Or could we just put, hey, this article already has 1,000 comments, like we don't need any more? There are more things we could do. We could say put some of the comments in the article document and store the rest of the comments somewhere else so that loading the first set of comments is very efficient. And if we want to load more comments, which is less often, you could put them in another thing. Or you could have like the extra comments are in a separate place, like sort of storing some of those comments in two places. I generally wouldn't worry about these until you actually hit a performance issue. Like if you're worrying about this before you even know that it's going to be too slow, you're optimizing too early, right? It's generally a good idea to make sure you actually have a problem before you try to fix the problem. So keep the comments in a separate collection or limit the number of comments. Those are both pretty easy options to do at the first time. And then there are other options you can pick up if you do find that you want to reduce the load or increase the performance or something like that. So if you are migrating, I would highly recommend doing a dark launch of the MongoDB version of your storage, making sure that you're picking up those performance issues, making sure that things that you're testing your flows before it's in a place where it's actually going to affect your users' requests and your users' data, right? But if you do find you want to optimize, MongoDB has a lot of levers to pull to be able to make some queries more efficient and to make your data structured in a way that fits your usage patterns. So one of those is indexes, right? If we had our comments in a separate collection, we probably want to put an index on whatever field we're using to match up those comments with those articles, right? The indexes in MongoDB are updated whenever you write. They're not kind of lagging or eventually consistent. They're right there ready for you to use. They're pretty easy to set up. For something like the popular tags summary, we don't want to necessarily scan over the entire articles collection to find all of the popular tags, especially since this is on the homepage of the app. So if that's working fine, we might as well leave that as is. But if it is slowing down loading the homepage of this app, we could add an on-demand materialized view, essentially cache the result of that query, and then have that updated once an hour, once a day, whenever we need it to be. And in some cases, you might want to store 2 copies of the data, which you can update in transactions across documents. It actually surprised me when I started working at MongoDB to find out that it does full ACID transactions across pretty much anything. If you used MongoDB 10 years ago, that was not the case. So have a look now if you're like, oh, but I need transactions. But yeah, there's a whole bunch of different options that you can use to adapt your data, and MongoDB has a lot of ways to do that. So this was the MongoDB relational migrator. So we've gone through sort of copying the data over. That's what the tool does. But there are a lot of things about the rest of your app that would have to be considered in part if you were to migrate your app from a relational database into MongoDB. Because the way that your database works and the way that your database structures the data tends to leak out into other parts of your app. So in this example app, in the web server, the code is structured around the table names. There's lots of different cases where the tables are basically written into the code. It uses SQL alchemy. The objects that it used to represent each table is very, very closely tied to the way the table is structured, which means migrating your database means refactoring a large amount of code. In the same way, if your database uses integer IDs and those are parts of your API or parts of your URL, then that can make it harder to change as well. This is another thing. This example app is actually pretty good. It uses like the slug of the article or the unique username of each user in the visible URLs. There's just this one case where if you delete a comment, it's using that unique integer ID of the comment as part of the API there. So that wouldn't be too hard to change in this case. You could change it to use a comment like a different kind of ID in the same structure. But it does mean changing your UI code so that it's not using an integer there. Yeah. But also, it changes the way that you think about your data. If you're building on a relational database, you tend to think about data in a relational database way, and shifting that thinking can take a little bit of time as well. But we are working on tools to try and make some of the code refactoring parts easier. So if you're interested in working on that stuff, if that sounds like an interesting and challenging problem to you, like it did to me, come talk to me because we are hiring. But overall, data migrations are hard. And at MongoDB, we are working on making them less hard. And I find this a pretty fun and interesting thing to work on, and I hope you do too. Cool. Thank you.
Thank you very much for the presentation. We will now open the floor for questions. Oh, that was easy.
Hello, thanks for the great talk. So regarding this migrator, how is the performance of the migrator? And for example, for some million or billions of rows, and also does it have some downtime for the relational database?
Yeah, so the migrator itself, so it has a couple of different modes that I didn't go into. So you can do we're just copying the data over. It will drop the collections that are there and copy the data over. And you probably want to do a maintenance window for your app if that's the way that you're sort of swapping over to the new version of it. There is also a CDC change data capture, so you can sort of copy the data over. It uses Debezium to sort of read all of the changes and all of the existing data from the relational database. And then there's a tool, if you wanted this to be a kind of highly available, long-running process for a really, really big database, you can set this up with Kafka. There's sort of tools to do that, to copy all of the data over into MongoDB, and then keep it up to date. If the data is still being written to the old database, those changes get propagated across to MongoDB as well. And then in that case, if you do want to do the switch over, you can you just have to wait for the last couple of writes to come in and then switch over to MongoDB. Now, if you wanted to do a completely zero downtime migration, then you might need a different approach again. You might need to do some kind of dual write system. You might need to, there's a whole bunch of different ways to approach that, but the relational migrator doesn't solve that for you. Yeah, we are working on more tools to help with that though. Yeah. But in terms of performance for a really big data set, we have had customers do really quite large, like many gigabytes of data or terabytes or something. I'm not sure. I don't know what the largest one is. Maybe Adrian knows. Yeah.
Hey, Katie. I manage a collection of templates for different, like choose your own adventure Python templates at Microsoft for like Django, Fast API, Flask, and then you get to choose your database, Postgres. Mongo is one of them. And I would like to improve the documentation to say when you should choose which database. So why would you choose Mongo when you're starting out in a project rather than migrating to something? So I can give it a pitch in the templates.
Oh, so like when should you choose to use MongoDB for a new project?
Yes.
Or yeah. So if you're starting from scratch, like that is a much better time to kind of choose a database. If you're already like built on top of one database, then like migrating is obviously hard. It depends a lot on, so one of the factors that you do have to consider is the engineers who are going to be working on this, like what are they familiar with? Because they're going to have an easier time. Are you willing to learn the new system? MongoDB has a bunch of nice features around full text searching or vector searching if you're doing an AI project that you would have to use a separate system for with a lot of other databases. If the data model that you're trying to store lends itself well to these nice documents of a reasonably limited size, it is good. If it's something like this social media app where it's all about who's following who and who's liking which one, that's actually not a super great fit for a MongoDB style data because it's all about taking these tables of information and joining them together in different combinations. And that might fit better with a relational database. So it's really hard to know at the beginning of a project necessarily like how the project's going to evolve and like what the shape of the data is going to be going forward. But there are lots of great databases to choose from, and I don't think you can really like go wrong unless you pick something that's really expensive, maybe. Yeah. Yep.
Hi, thanks first. When you embedded the tags in the article document, if you change the name of one of those tags, like say from conferences to conference, will that update in all the articles, or have you now essentially cached it in there?
Yeah, it's essentially...
Because like in Postgres, right, it will just, because you're only changing it in one place, but will it actually propagate?
So in this case, it won't.
Right.
So it is actually just storing, like each article owns its own tags. And if you change the tag in one article, it's not going to affect any of the other articles. So you're right, it has changed the behavior a little bit, where in Postgres, if you changed one of those rows in the tag table, it would change that tag for every article ever. In this case, this is one of the cases. This is why it's a tool that lets the developer look at the schema and make those decisions themselves. Because if I'm working on this app, I happen to know that we never actually change anything in the tags table. We never change one of those tags. And so that wasn't a feature that needed to come across into the new version. But you're absolutely right that the behavior is different there. Yeah.
And I think the session is going to conclude in a minute. So if you have any other questions, feel free to bring it up with Ms. Bell afterwards. I'm sure she'll be happy to answer them. So to thank you for speaking at this year's PyCon, I'd like to present to you the speaker mug thing.
Thank you.